Don't go anywhere because we have our next full panel for the day. This is blockchain scalability, taking blockchains on another level, literally. Blockchain platforms work, but how well do they work at scale? Will they be able to scale in a practical way without compromising decentralization or security? This panel looks to discuss the development taking place particularly between Layer 1 and Layer 2 solutions. Please remember that if you have any questions for the panelists during the discussion, go to www.slido.com. Enter the code BlockShow2019, select stage 1, scan the QR code on the screen, and write down your question. Now, please welcome your moderator, Colin Charles, and panelists Max KORDEK, Matthew Tan, SRIRAM, and XINXI Wang. Thank you.
So I guess we're starting on time, actually. Good afternoon, all of you. Got a wide variety of folk on the panel today. We've got Max from Lisk, SARANY from Microsoft Azure platform, XINXI from Litecoin, as well as Matthew from Etherscan. So we hear definitely a lot about capacity planning, scalability, getting blockchains to another level, going from 1,000 users to 1 million users to 1 billion users. And we also hear a lot from people in China that say that the scalability problems of the Western world are basically problems that they face on day one because they're so large. They just launch with like 3 million people. So today we're going to talk obviously about blockchain scalability from various aspects, the open aspects, the enterprise aspects, and so forth. So I'm going to give everyone exactly 30 seconds, and I will stop you, to pitch a little bit about yourself and what you do and what you're going to be bringing to this discussion. So, Max.
All right, so my name is Max KORDEK, CEO and co-founder of Lisk. We are doing scalability in terms of like building a blockchain SDK, which enables any developer to build their own blockchain very easily and fast, and later on connect that as a sidechain to our platform. And that's our scalability approach to blockchain.
Excellent.
Hi, I'm SARANY, a cloud solution architect lead here. So essentially, we work on blockchain projects, non-ICO, non-crypto, but mostly on various other use cases and works, and even in the financial sector. Happy to talk about that.
Thank you. XINXI.
Hello, everyone. My name is XINXI Wang. I'm from the Litecoin Foundation, and I also do exchange which named Coin Ultimate Trading, coinut.com.
Matthew.
Hi, my name is Matthew Tan from Etherscan, and we build block explorers. That's what we do.
Thank you. Short and sweet. Now everyone knows what you guys all do. So, blockchains, many of you obviously have dealt with this for several years at least. Famous for their immutability, transparency, decentralization, security. And we've seen that Bitcoin transaction verification happens with proof of work, can be a little slow. Can you actually have security, scalability, as well as decentralization, all three, or can it only be 2 out of the 3? What are your thoughts on this?
Yeah, so I think there are always trade-offs. Like you cannot have like unlimited scalability in a totally decentralized environment. I'm always laughing if I see projects who are like promising like 50,000 transactions per second, and like it's all crazy. But I think it's very important to not sacrifice the important values of a blockchain. I think that's why we're all here. And therefore have to find use cases of blockchain technology where you don't have to have the scalability of Visa. At least nowadays, in 10, 20 years, maybe we reach a level where we can achieve that kind of scalability. But I think we have to start slowly.
Fair enough.
So I'd like to take a step back when we talk of scalability, because databases and distributed data scalability is an academic issue for many, many years, right? So when we now bring the context of blockchain, at least from what we've observed, scalability of data and getting, say, X transactions per second, that's something that everyone really wants, can actually be optimized on the hardware level, can be optimized at a cold, which is smart contract level, like you can actually optimize that, can also be optimized based on the network configurations and integrations, and then APIs that make it flexible. So all in all, on the distributed database front that you're saying, one thing that will be interesting to observe is in the scalable databases, what is the consistency that we want? Today, we're probably looking at strong consistency and eventual consistency, but in the market, you have pit stops of you could have bounded staleness, which kind of says in a window of X units and K time, I can get you staleness, or I could do all the reads will be stale. So you have options to play around, and blockchain can very much take off credit of all of that beyond the base layer of network, the layer of APIs, and the hardware that I spoke.
It's a very good take. Enterprise, very enterprise take.
And by the way, not from Microsoft, I'm here also as an individual. So I'd like to say that when we talk of offerings as an Azure blockchain service, it's a very open platform with open tools. And that's something that when you play around and dev on it, you'll soon realize.
I do believe that there's always a trade-off between the three. For example, for Bitcoin and Litecoin, we always choose decentralization and security instead of scalability. That's why Bitcoin and Litecoin are all very slow. They can handle like 7 or 28 transactions per second. But for some other applications, like the payment system that China is building, they have to handle like billions of transactions every day. So they have to choose security and the scalability instead of decentralization. So it has to be a very centralized system. And these two are the two extremes in the whole blockchain world. And everything else should be in the middle. They trade off from different aspects.
Correct. Trade-offs are important.
Yeah, so I'm going to start off by probably like what do you define scalability? I mean, scalability, is it like infinite scalability, finite scalability? So if you're looking for something that's closer towards infinite scalability, use a database. If you're looking as far as blockchains are concerned, I think the issue here is like how can we make them more scalable? But given the way and the nature blockchains work, it always will be a finite scalability. So you don't expect 50,000 TPS on a decentralized blockchain distributed ledger. Yeah, so I think it's also like what do you define scalability as?
Correct. Okay. So I guess the general consensus here is, see, got to use the right terms, is that TPS, transactions per second, may not necessarily matter so much because you want to also keep the other things alive, like security and decentralization. But if you're building a national payments network like China is building and Facebook is attempting to build with Libra, they would need more scalability and security, but not decentralization. So, we have obviously got some open chains, open chain tracker, open blockchain. So sharding is a very popular topic as a way to scale things, and sharding is something that ideally has also come out from the site reliability engineering database world. Lightning also took this option by basically going for Lightning forked and also chose to build on top of another layer. Litecoin forked. It's Lightning that built on top of another layer. Bitcoin Cash forked as well. So you split transaction verifications into shards to increase throughput. And does it matter? Like, how has Litecoin fared compared to others? How has Bitcoin Cash fared to Bitcoin? You can start.
Sorry, what's the question?
Yeah, so the question is, does sharding or forking actually help? Litecoin,
Uh,
and
so-
other open networks?
So Litecoin chooses decentralization and security instead of scalability. But on top of Litecoin, we are building a second layer called Lightning Network, which chooses scalability and the security. So it may cause some centralization, but this Lightning Network is revolutionary because it can handle millions of transactions per second, or even higher. But so the two layers work together to mitigate the shortage of each other. One is not scalable, one is scalable but centralized.
So a layer 2 that is scalable.
Yes, yeah.
So very much like Lightning and Bitcoin. Anybody else have an opinion on this?
Yeah, sure. So first of all, I have to say, like in terms of forking, sometimes I'm a fan. Like in terms of Litecoin, you're actually doing something. But in terms of Bitcoin Cash, for example, I'm not so sure. So I think forking in itself is not a solution. Okay. Lightning, I'm a big fan. I think that will going to be revolutionary and really, really big in the future. But there's still a lot to do on the user experience level, and it's really young technology, so it has to mature a bit. So in terms of sharding, I think it's an approach. For example, if we are speaking about Ethereum, they try to put everything on one chain, but that's obviously not going to work. So they will have to like somehow separate that. In our case, what we thought of was, okay, let's not put all the apps on one chain, let's put one app on one chain. So you will always still run into scalability issues, but with one app only, it's much more like likely that the scalability demands will not reach the maximum, like the peak too early. I don't know how many smart contracts are running on Ethereum right now.
A lot.
You can tell us.
Yeah. But like, just imagine like probably 20,000.
Define smart contract. There are definitely more than 20,000
Okay.
contracts.
So the thing is with smart contracts, like for every interaction you have to pay. So on the network, right? You have to pay a fee and
At this
so
point
on.
in time, yes.
And that you do much less. Because like, for example, CryptoKitty is one of the most popular ones. It has not many interactions per day, actually. So
yes.
if we're speaking about a blockchain, like in our case, which can in future handle around 1 million transactions per day, that's pretty much sufficient for many use cases already. So we do not sharding, but like we split up blockchains into like different, in this way, you know?
What might the Ethereum?
Yeah, I'm just going to add in from what Max said. So I think, a lot of times you don't really have to reinvent the wheel, right? Sharding is a proven tech. I mean, it kind of works. We know it works. But first, like, how do you apply the same concepts to decentralized chains? So I think the part Ethereum will take forward. So right now at Ethereum, you probably can do about 15 transactions per second. With the ETH 2.0, which will eventually come, we're looking, so the initial plan was to break it up into 1,024 shards, which would give you approximately about 15,000 TPS per second. There has been revisions to that. So right now we're probably looking to about close of half of that. So looking about probably 78,000 TPS per second. So I think going forward, I'm definitely excited. See how that pans out. I think it will solve a lot of issues that you just mentioned. And with different shards, you will have, it's possible to have some shards without transaction fees. That's definitely one possibility. It wouldn't be app specific. It would be more like segment industry specific for each shards. That's the way I see it.
Right. So I guess one thing about sharding is that it also adds application complexity on top of it because things process independently and also they need to sync automatically later on and you're doing asynchronous transactions basically. So I come back to you with regards to a bit more enterprise use cases. So this week we can all celebrate the fact that a bank did a letter of credit transaction with the Voltron trade finance platform. But many surveys that I've read, when analysts do surveys with enterprises, they always say, look, we're very interested in the blockchain, but scalability is an issue for us, and scalability across multiple apps is an issue for us. Whereas the open chain folk are more like, yeah, we know our limitations, and we'll work around them and we'll build a layer 2. But enterprise thinking is still very, very different. Possibly still everyone's writing in Java, for example.
No, it's a very fair question, and it's a real issue. It's a real issue because in the enterprise, they always want to look for worst case scenario, right? So they really want to ensure that they provision extra and they are able to have access to that. First and foremost, when we are looking at not public but private blockchain, talking from the Azure blockchain offering, either you can set your own private on infrastructure as a service, which is directly take the machines. That boils down to scaling on these machines. So how can any cloud platform, it could be GCP, AWS, Azure, anything, how strong is the hardware? Like, are they on Intel SGX? Are they having at the hardware level connections and scale? So that's one point. And beyond that, how are they able to segregate that into a consortium nodes that can be added on? And on these nodes, how is shards created? Beyond that, at every transaction level, and those nodes, can we optimize that? So they're looking forward to any public cloud when they are looking for any deployments. They're looking for hardware security, safety. They're looking for smart contract, which is API level access fidelity. And they are also looking, as I said, for the right industry use cases for that. So all in all, the way we are seeing with Azure Blockchain Service, there is support, for example, for Quorum. There's support for Corda. So these are all very enterprise blockchain focused. And of course, they say that you can go and create any other chain at an infra level that you want. And gives a lot of weight to the API users, depending on any language that you want to write your API on, and how you can optimize those queries.
So are you seeing any of these private blockchains eventually, maybe potentially becoming more connecting to the public as well?
So we'll more focus on open blockchains. So I think if you want to run stuff in the private, just use a database.
So not a fan of Corda or Quorum?
So on that front, the proof of work is there. But then there is this idea of across industries when I talk to retail, supply chain, or manufacturing, where energy consumption could be one, optimization and quickness of identifying the right nuns and the right connection could be another. But whatever may be the reasons, there seems to be certain use cases where people feel more comfortable or confident to have a private one.
So I think we're kind of seeing that evolution with the intranets and internets, right? I think eventually someone smart will figure out a way that they will go the way the internet is gone. I don't know.
I think what China is doing is a giant private blockchain-based application, because the governments don't want the public to control it. So the central bank will have very high level of control of everything, and no others can do that.
Fair enough.
Yeah, that's pretty much private to the government.
And that's probably why America is so afraid of Libra, because they also think, look, you're going to be becoming a central bank run out of Switzerland.
Yeah.
And controlling a bunch of currency, and you're a private company.
So most blockchain networks that we seem to be proof of stake, bit of proof of authority as well, and then using various other consensus algorithms.
Yes. So interestingly, now that you mentioned proof of stake, so there are many scalable consensus algorithms that enable scalability. So we've seen things like practical Byzantine fault tolerance, which is what Hyperledger uses, and they were right here before we came on stage. And Ripple, Stella, they use federated Byzantine fault tolerance. Got proof of authority, of course, and Lisk uses delegated proof of stake. So, any of these going to, win? We see a lot of press around Ripple, for example, and, Ripple and banks, for example. But then people don't realize that that's not XRP Ripple, that's Ripple's banking technology, core banking technology. So how does Lisk look at this when they use, when you use delegated proof of stake?
Yes, so yeah, Lisk is using delegate proof of stake. In the beginning, we were asking us the question, okay, do we want full decentralization or do we want to find some middle way? And we looked at consensus algorithms and we came to the conclusion, okay, hey, for full decentralization, for digital cash, there's Bitcoin, there's Litecoin, there are others. We're more about like building a platform for applications, and it needs to have a certain scalability in itself, but it doesn't have to be like the most decentralized platform in itself. In our case, there are 101 validators, in future 103, which are like taking care of generating new blocks on the network. And in terms of scalability, this of course helps tremendously because you don't have like basically any computer in the world who could from the probability aspect like generate a block. You just have these 101 actors who just one by one generate new blocks. And every round it's like randomized so that you cannot DDoS the next node and so on. But it has its certain sacrifices as well, of course. But it's, for us, a very good approach, yes.
Fair enough. Anyone else got a favorite scalable consensus mechanism?
I think there's no best for all kind of things.
Yeah.
For a company alone, it just needs a database, maybe with a journal, which looks like a blockchain, but it's not. And for a few companies working together, they may need a federated blockchain, which is private to them, and it's going to handle much more transactions per second. And for the public, which requires very high level of security, then it's going to be a public blockchain like Bitcoin, Litecoin, or Ethereum. And for China, it's going to be a very different thing. So I think for different applications, we need a different level of scalability and other trade-offs.
So there is no one-size-fits-all, basically.
Yeah.
I think look at use cases, right? So just like it's at the end of the day, it's use cases. Like you have different use cases for POS-based POS blockchains. Looking at Bitcoin and Litecoin, I don't think there will be a time that you will move to a post-based stake, right? So that will always be proof of work. So I guess it goes back to use cases. And if you look a little bit deeper down, right, it also goes back to the community. There's a lot of infrastructure in terms of miners that do a lot of proof of work. Mm-hmm. So I don't see this. I mean, this will always stay the way it is. There will be segments that will want to do proof of work, segments that want to do post-based, depost. It's all about choices.
So it's like going to Starbucks.
Yes, yes.
Or Coffee Bean.
Fair enough. We don't have a coffee preference, clearly. So, one more thing back to the enterprise use case maybe is we have heard a lot about scalable distributed ledger technology, or DLT. And many of them use distributed acyclic graphs, DAGs, which if you've written code and use source code management, distributed source code management systems, they mostly use DAGs for history. So, are we seeing DLTs being popular still, or has it gone the way of blockchain, not Bitcoin?
It's a very interesting question because as much as this technology is real and it's advancing fast, there's still a lot of legacy in the enterprise where people are still stuck to either relational databases, heavy, sticky, even NoSQL data components which have a certain schema attached to it, things like that. So to kind of answer the question, like, are people shifting to the right kind of data structures that relate to blockchain very easily? I think it's a journey. One thing from Microsoft and from the Azure that I'm seeing, and the industry when I'm seeing, I see that people want flexibility. One is they want connection endpoints to SQL Server, or it could be any other SQLs, for example, Corda, in fact. But on the other hand, there's also these newer databases like the Cosmos database, like the Google Spanner, etc., which is distributed databases which have built on components such as the TLA Plus, which focuses purely on how can I get multi-phase conflict resolutions when I access. And these databases are easy to set up. You can just write JSON scripts, create a schema, like put it in an event store, could be any bucket store, and then access it over API. So newer additions, like a Bank of Indonesia says, hey, I want to build an eKYC on blockchain. For that, I want to set up a new database because I probably want to interface with existing, but also add new databases. Then they'll choose a hybrid combination of both.
Fair enough. So, because we have to have 5 minutes for questions, I'm going to ask one maybe softball question. So, Ali Yahya, a partner at A16Z Crypto, Anderson Horowitz, he basically recently did a tweet storm, and he said that crypto networks have the potential to evolve into the infrastructure of the next generation internet. Once this revolution has played out, there will exist applications as complex as Facebook that are decentralized and open source. Many words I like decentralized, open source, Facebook. So, if blockchains scaled, for example, will dApps be mainstream? Will we be using a distributed Facebook? And we can start from you,
Yeah, sure. So, I mean, that's exactly what I'm working on to make it happen, right? And that's why I would definitely say yes. We still have many challenges to solve, though. I'm not sure, if everything will be built decentralized. I don't think so. But I'm quite sure that in the future, open source will become much more prominent than ever before. And we see Microsoft moving into that quite dramatically recently. But we have to ask the question, decentralization in what way? Blockchain is one way, but it's existed long before with torrents and other networks like that. So if we're talking about applications for the mainstream, we really have to see what do the mainstream want. And I think they don't want decentralization. So it has to bring them a benefit which they might not even realize, but we realize it, and we just want to help them to be maybe more private in their life. Facebook is a data monster, right? And they're just selling everyone's data to people, and no one likes that. But people just don't care about that. My sister, my friends in my hometown, they just are all on Facebook and sharing pictures and liking some posts and so on. So I think it's up to us to introduce applications in the future which prevent basically the businesses from actually doing that.
Right. Aggregate data sometimes is worth more money than individual data.
Yes, yes.
I think it's a huge responsibility for us. Technically, it's not stopping because this distributed computation is something real, and people are also advancing it, so it's going to happen. It's how much of liability that we as a society want to take on for it. So I think I feel it real. I feel people are making trades, leaps and bounds on how they can create rules. Like on the enterprise side, GDPR is just one thing that has popped in to say, how can I ensure data, which is across, can be traded equally? Now, how can it be brought into blockchain kind of apps, like smart contract apps and other dApps, where they respect data and also how they can create? And crypto, public key, privately, security has been there forever. So it's, I think, a culture change.
Okay.
Well, I'm not sure we need a blockchain-based Facebook.
Okay.
Maybe we don't need that. Maybe we just need some personal websites which can communicate with each other, just like how you are using Facebook to view other people's information. Maybe just directly pull the information from other people's websites. So it's even more decentralized than a blockchain.
What about a decentralized Google Docs in that case? Would we need that?
Yeah, but Google Doc is still backed by Google Server, which is decentralized.
Yeah.
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 Could we have a Google Docs that's a dApp, for example, do you think?
If it's a dApp, everything is put on the blockchain, then it's going to be a very big problem.
Okay.
Yeah, I'm not sure it can be done through blockchain.
Fair enough.
But I also think it's more about hybrid approaches. So there could be a notary service within Google Docs, which is actually built on a blockchain, and that actually might make sense.
Okay.
So I tend to agree with what Cincy said, right? It seems like decentralization. Throw it to any problem, and it's the solution for any problem. not everything needs to be decentralized. I would rather see an environment where users are given a choice, like you might have a decentralized version of Facebook, and users are given a choice whether they want to interact with the centralized versions or the decentralized versions. So it's all about giving users choices and letting them figure out what's best for their own needs. Not everyone needs to be decentralized. Not every application needs to be decentralized.
Fair enough. So maybe we don't need decentralization for everything, and we should be generally happy with our scalability efforts and the progress that it's taking over time. So we're actually open for questions to this Slido app, though maybe all of you are not asking any questions. Does anybody have a question? You can even shout one out. We have 1 minute left. Tough topic, scalability. Yes. How can you achieve true mass adoption of blockchain if every change
in state? So every transaction that occurs on some chains, okay, every time you do a change of state, there's an incremental charge, right? So and understood that works in some environments, but in open real world environments, you can't charge for every transaction change.
banks will differ on you on that? Don't they charge you for everything you do? But yes, can we achieve something?
Yes. So I think it's really about the use case, and like that's why we want to enable developers to just experiment with blockchain first to see like what makes sense. I think like for example, if you would KYC yourself and somehow a blockchain is involved to like that you could publicly prove that's you or whatever, then maybe you're willing to pay a minimal amount of fee for doing that, because it's actually a benefit to you. So I think it's just about the use case, but I have to agree, not everything makes sense, and like the regular people on the street don't want to pay 5 cents or $1 or whatever just to send out a tweet or whatever. So it's really about the use case in my opinion.
Yeah, I would agree completely. And then the choice of whether you want to use proof of authority or proof of, stake. Exactly. So in situations where proof of authority, then there is a legitimate use case that will authorize, and there's an option. In terms of proof of stake, it's also the fact that how much of stake you have in the Ether or in the system that's available. So there could be definite use cases that legitimate, but I would completely agree with what you said.
So I'm going to take one step further back, right? I think so. Nothing is free. Even what you think you're using today is not free. It's just that who's paying for it.
Yes.
So at the end of the day, someone's paying for it. You send an email, Google's paying for it. Someone is paying for it. It's just who's paying for it. Is it the user paying for it, or someone else paying for it?
That's a very good take. So I'd like to thank you, Max, Saranya, XINXI, as well as Matthew for this wonderful panel, and I guess at some stage there's going to be lunch. Thank you very much for listening, everybody.
Thank you.
Thank you.